Ladies and gentlemen, welcome. This is again our 4ST441 Statistical Methods and Capital Markets, our seventh seminar. If you remember, on the previous seminar we finished with some small experience with Arma process, which was not successful. So today we will start again with this Arma process, other Arma processes, and after we will practice a lot because we already know a lot of theory. So this seminar will be more practical. I will show to you some real examples. Modeling of real-time series, and we will try to forecast. So I think that we can start, and we will start with the first example. There is exercise 26 where we would like to generate a realization of an Arma 1-1 process again. Yes. AT is a Gaussian white noise with unit variance, and we have here four formulas. Four formulas for the creating of these Arma processes. Xt will be equal to 0.2 times xt minus 1 plus AT minus 0.9 AT minus 1. There is the part, there is auto-regressive part, and there is moving average part. Yes. So we will use different values of parameters phi, 0.2, 0.9, 0.8 and 0.6, yes, and different values of parameter theta, minus 0.9, minus 0.1, plus 0.5, plus 0.7. Yes, we'll explain how the time series were generated. We'll calculate the sample and true autocorrelation function, the sample and true partial autocorrelation function, and we will discuss the result. If it will be possible, we will try to forecast time series. You probably remember that at the end of our previous seminar, we generated two Arma processes. Yes, on basis of generated Gaussian white noise process. Yes, and when we transported these processes to Eviews software, and we estimated autocorrelation and partial autocorrelation function, there was no significant system. There was no significant correlogram. And therefore, we said that this was not successful generation of Arma processes, which can happen. Yes, it's normal. It's possible. Yes. So today we will use this Gaussian white noise process, which I generated randomly in Microsoft Excel, and this Gaussian white noise process I already sent to your school email addresses, so we will have the same results for comparison. So we have here Gaussian white noise process with 500 values, and according to formulas which we have in our slides, we will generate 4 new Arma processes, with different parameters phi1 and theta1 on the basis of this Gaussian white noise process, which we have the same, everybody the same. Yes. So we'll start here in this beacon. We must start in the second row because there is a label, Gaussian white noise. So on the first position, there is only a value from white noise process because we don't have previous values of variable xt and previous value of Gaussian white noise. Okay. And now we will use parameter phi 0.2, yes, 0.2 times my previous value, yes, plus value of white noise process on the row where I'm placed minus 0.9 times previous value of the Gaussian white noise. Yes, okay, so this will be the first Arma process. And we can continue, yes? We can continue, we can name this, for example, Arma 1. Okay, we can continue here. Again, on the first position, there is only the value of Gaussian white noise. And we will start here, so equal sign. We will use parameter phi 0.9. Yes, 0.9 times my previous value, yes, plus white noise, which is placed on the row where we are, yes, minus 0.1 times the value of Gaussian white noise from the previous observation. Okay, so this can be copied to the end, yes. And yes, we have Arma 2, we will create Arma 3. On the first position, there is only a noise, yes, a value of the noise. And on the second position, we will use parameter phi 0.8. 0.8 times my previous value plus value of white noise on the row where we are placed, yes, plus 0.5 times the previous value of the Gaussian white noise. Okay, so we have here Arma 3 process and Arma 4. There is again only a noise, yes, enter, and there we will use parameter phi 0.6 times previous value of xt in x time t minus 1 plus noise, white noise on the row where we are placed, plus 0.7 times the previous value from the Gaussian white noise process. Okay, so you have here 4 Arma processes, and we will copy this to Eviews. But in front of this, we must delete the formulas. So again, copy and paste values. Copy and paste values. Yes, so please select this, copy and paste values 1, 2, 3, 1, 2, 3, paste values. Okay, we deleted formulas. Now we must change commas to dots. So we will use the shortcut Ctrl H, yes, find and replace. We will find commas. And we will replace with dots, yes, and we will click on replace all, and there will be a message that we changed and we made 2000 changes, yes. Okay, so this is ready for Eviews. I have already opened Eviews here, so there is Eviews window. We will click on File button, New, and Work File, yes, we will create new work file. There, in case of frequency, we will select integer date, start date will be 1, end date 500, yes, okay. So there is a new window, new work file, and we must create here 4 new files, yes. So we will write commands, series. And for example, we will name our processes like Arma 1, Arma 2, Arma 3, and Arma 4. So we will write here Arma 1 equal to 0, Arma 2, series Arma 2 equal to 0, enter, yes, and the series Arma 3, series space Arma 3 equal to 0, and the series Arma 4 equal to 0. So 4 files we'll open these 4 files as group. Yes, the right button will open these 4 files as groups. Don't forget to click on edit plus minus, yes, because we must unlock this spreadsheet, and from Excel we'll copy these values, yes, copy Ctrl C, and we'll paste it here, Ctrl V. We'll close this, yeah, we can close this spreadsheet, and individually, yes, we can open 4 windows. Arma 1, Arma 2, Arma 3 and Arma 4, yes. We will open these 4 values here in Eviews, and first we will check the chart, yes, because we are interested, yes, on the shape of the development. So Arma 1, 2, 3 and 4. And in case of all spreadsheets, yes, click on View, Graph, and OK, yes. And we will check the development of the charts, yes. So View, Graph, OK. The development is different, yes. So again here, View, Graph, and OK, and finally View, Graph, and OK. Yes, so this is similar to this one, yes, a little bit, at least a little bit. This one looks like white noise, yes, but in the case of these two, for example, you can see there is a different volatility and development, yes. But it will be good to check the correlograms, the correlation structure, yes, in these 4 time series. So please, in the case of these 4 charts, yes, we'll estimate autocorrelation and the partial autocorrelation function. So view correlogram of level OK. Again here correlogram of level OK, correlogram OK, and here view correlogram of level. Perfect. So we know that in all cases we should have here Arma 1-1 process, yes, Arma 1-1. In the case of this correlogram, there I can see exponential decreasing in case of partial autocorrelation function. And one value in case of autocorrelation function is statistically significant. So in the case of this chart, yes, I can say that there is moving average process only, yes, moving average of the first order, yes. Arma 1 was model where we have strong parameter theta, 0.9, yes, and very weak parameter phi, only 0.2. So we cannot see here, yes, this parameter phi. There is significant parameter theta, 0.9, yes, so the moving average part is stronger than autoregression part, yes. I generated, yes, this Arma process, like Arma process, Arma 1-1, but autoregression part is not visible here, yes. For example, here, in the case of Arma 2, yes, in the case of Arma 2, we used parameter phi 0.9. So very strong parameter phi, very strong autoregressive part, yes. So this is the reason why you can see here significant coefficients, yes, autocorrelation coefficients, exponential decreasing, yes. And here we can say significant first coefficient, and maybe this second one is significant or not, probably not. So this is the situation where we had theta, only equal to minus 0.1. So very weak theta, yes? Very weak parameter theta and very strong parameter phi. So in the case of this situation, we could say that we have here only autoregressive process. Autoregressive process of the first order, yes? And we will move down, yes? You can see, for example, this development, Arma 3, and here we used parameter phi equal to 0.8 and parameter theta equal to 0.5. Everything must be evaluated in absolute values. So you must imagine this column on the right side, yes, in absolute values. And we have here exponential decreasing of values of autocorrelation coefficients. And here, if this column is on the right side, yes, you can see here exponential decreasing of values of partial autocorrelation coefficients. So this is very nice example of Arma process where is clean, yes, autocorrelation, partial autocorrelation structure, yes, of this process. Yeah? So there we have a really Arma process, and this is significant in this chart. Yes, we can say that it's visible here. And in the case of Arma 4, yes, again you can see here exponential decreasing of values of autocorrelation coefficient. Yes, we used parameter phi equal to 0.6. Yes, 0.6 parameter phi, and parameter theta was 0.7. Yes, so again we must evaluate everything in absolute values. So all these columns, imagine that you have on the right side, yes? So there is exponential decreasing of values of autocorrelation coefficients, exponential decreasing of values of partial autocorrelation coefficient. So again, we have a significant Arma process, yes? So we will use, for example, these two processes, Arma 3 and Arma 4, yes? For the calculation of forecasts, yes? So, on the previous seminar, we were not able to forecast anything because in the case of our two created time series, we don't have a nice example of Arma process, yes? It was not statistically significant according to parallelograms. But now we have two nice examples, yes? So we will use this and we will create a model, yes? So it's necessary to click on a quick button, estimate equation, and I said that we will use Arma 3. So Arma 3 will be dependent variable, yes? Arma 3 will be dependent variable, and we will write here AR in parenthesis 1, yes? Space MA in parenthesis 1. Don't forget at home, if you have a new version of Eviews, you must select instead of maximum likelihood ordinary least squares method. So you can click on OK, and there we will see the first example, the first model. In the case of Arma 3, we generated parameter phi equal to 0.8 and parameter theta equal to 0.5. You can see that estimated coefficient phi is equal to 0.77 and theta is equal to 0.4748. Yes, we have both coefficients statistically significant. So we will name this model, yes, so we clicked on name, yes, and there is written equation 1, so we will name this like equation 1 space Arma 3, yes, so this will be our first model, okay? So we will leave this model here, and next we can estimate second model. So on the top we can click on quick button and estimate equation. Yes, and our dependent variable will be Arma 4 and regressors AR1 and MA1. Yes. Okay. So okay, at home, don't forget to change maximum likelihood to least squares. So there is a second model, Arma 4, and if you remember, in the generation we used parameter phi equal to 0.6. There is estimated coefficient 0.54, statistically significant, and parameter theta we set on value 0.7. We have here 0.70, 0.71, yes, again statistically significant. Okay, so this is the second model. We will name this model like equation 2, equation 02, space, and there will be Arma 4. Yeah, this is Arma 3, so there we'll use Arma 4. Okay, and we will use these two models for forecasting. But today we have new work file, so it's necessary to add here a space. Yes, so we must return to work file. Yes, so where is work file? Where is our work file? There is work file. There we must maximize the work file. Okay. Please double click on 500 observations, and again we will add here. I don't know. It's enough. I think that it will be enough for 520. Yes, 520 only. Okay, 20 observation. Resize involves inserting 20 observations, only 20 today. Yes. Okay, we can recalculate parallelograms. Okay, so our two models, equation 1 and equation 2. Yes, equation 1, equation 2, we have already a space for forecasting. So in the first case, we will click on forecast. And the forecast name will be Arma 3 forecast. We will create standard errors, so please rename standard error 3 forecast, for example, or standard error 3 forecast. Forecast sample will be 500 space 520. Yes, because this is maybe 501 to 520, yes, because until 500 we have a data, yes, and from 500 and first observation there is a start of the prediction, yes. So click on OK, and you can see that until I don't know, observation 511, 512, we have a forecast. And after, the prediction is 0, the conditional mean, yes? But Arma model has a little bit more memory inside, more than simple AR1 or MA1, yes? Like we seen in the previous seminar, where our prediction was only, for example, 1 or 2 values, future values, yes? There is a little bit more memory in our data set, yes, so we predicted a little bit more, yes, and after prediction will be a constant, a line, a conditional mean. And this we will try to do one more time here in the case of second significant Arma model. So we will click on forecast button, yes, and our forecast name is Arma 4 forecast, yes. Optional standard errors, we will write here SE4F like forecast, SE4F like forecast, yes. And forecast sample will be 501, yes, because 501 observation is the first unknown observation. Until 520, this is our horizon, yes. If you are at home, Don't forget, oh yes, there is our model, so our forecast. So please click on OK, and you can compare this development with this one. Okay, so until this, I don't know, 505th, 506th observation, probably, yes, is the last one where is some value we can observe spreadsheet later, yes. You can see that there is minus 0.0 and no decimals, yes. But after this point, as the prediction is probably 0 or very close to 0, yes. But again, as I already said, there is a little bit more memory, yes, in these models, Arma, in comparison with simple AR or MA, where the prediction was 1 or 2 values, yes, and after the conditional mean, yes. We will close these two windows, yes, and we will check a spreadsheet of Arma 3 forecast and Arma 4 forecast, yes, and we will scroll down. So Arma 3 forecast, Arma 4 forecast, and we will scroll down because from position 501 there is a forecast, yes. So we will scroll down. Okay, 501. Yes, you can see 0.61 minus 0.47, etc. And here, yes, you can see observation 515 minus 0.015, yes, 516 minus 0.009, yes. And each other value is closer and closer to 0. So you can see on the position 520, as we have only value minus 0.004088. Yes, here probably this development, yes, this limitation to 0 is faster. You can see observation 507, yes. Value minus 0.0076, yes. There, 515, there is a value minus 0.0000548 because there is an exponent minus 5, yes. There on observation 519, there is exponent minus 6, yes. So minus 0.0000464, yes. So it's very close to 0. There is a less memory in comparison with this model, yes, because we have here probably a stronger parameters, yes, a little bit stronger parameters. Phi equal to 0.8, theta 0.5. Here we had the theta 0.7, but weaker parameter phi, yes. So we forecasted the time series, yes, and we discussed the results. Okay, so about Arma models with order P and Q in general, yes. Arma models, it means order P in autoregressive part and order Q in moving average part, has the following form, yes. X in time t, as value x in time t is equal to phi 0, which is intercept, a constant, yes, of the model, which can be present in the model or not, in the case that constant, the intercept, is not statistically significant, and plus phi 1, x in time t minus 1, phi 2, x in time t minus 2, etc. until phi p, x in time t minus p, plus at, which is a value from the white noise process, yes, and plus there will start the moving average part, yes? Theta 1, A in time t minus 1, theta 2, A in time t minus 2, etc. So some parameter theta times locked value of white noise process, yes? A in time t minus 1, t minus 2, t minus 3, etc. until theta q, A in time t minus q. So in the part of auto regressions, yes, we have a correlation. Of previous values of dependent variable x, yes, and in the part of moving averages, yes, we have a correlation of locked values of white noise process, yes. So I already said that phi 0 is intercept, phi 1, phi 2 until phi p are parameters, theta 1, theta 2 until theta q are parameters. AT is white noise with zero mean and constant and finite variance. Okay, you can continue. How to determine orders P and Q of Arma models. Yes. In contrast to auto regressions and moving averages, yes, neither true autocorrelation function nor the true partial autocorrelation function of the Arma processes, Arma models, is useful for determining the orders P and Q. Why? Because if we have a significant autoregressive part and a significant moving average part, yes, it's possible to observe significant exponential decreasing of columns of autocorrelation function and also partial autocorrelation function, yes. So you can see that there is a dependence, yes, significant coefficients, yes, in the chart of autocorrelation coefficients, and as well significant coefficients in the part of partial autocorrelation coefficients, yes, but we don't know if there is stronger auto-regression part or moving average part, yes, or if there we have present auto-regressions and moving averages, etc. So it's a little bit more complicated. To select the orders of an Arma model, there is a good method, trial and error. Yeah? So it's good to use, for example, AR1, MA1 as in our equation, and check after the estimation of the model to check the next development of autocorrelation and partial autocorrelation functions, if there is still any system or not. Yes, so we must evaluate the residuals after each estimation of the model. Yes? So this technique is quite useful. So trial and error can be implemented. Namely, we try different values of P and Q, starting with low orders, as I already said, for example, Arma 11, yes, and check the model using the residual diagnostics. Yes? We must check the residuals after each estimation of the model to observe if there is still any system or not. If there is no system in residuals, yes, our model seems to be good. Yes. Another possibility is to use information criteria to select the orders P and Q. About information criteria, we will say later. Yes. Now I can say to you that, for example, in Eviews software, we have installed three types of information criteria: Akaike information criterion, Schwarz information criterion, and Hanan-Quinn information criterion. The Schwarz criterion in other softwares, maybe for example in RStudio, etc., is named Bayesian information criterion because Mr. Schwarz Gideon was a Bayesian statistician. Yes, a Bayesian statistician. So in other softwares, this criterion is named Bayesian statistical criterion after Schwarz Gideon. Yes? So these three information criterions, and information criterion is a statistic which penalize you, yes, if you, for example, use wrong order of the model, non-significant variable, yes, if you have a system in residuals, yes, autocorrelation, etc. So you are penalized, yes, and the main information now at the beginning about information criteria is that the lower, yes, if you have a lower value of information criteria, you have a better model. And lower means that -10, yes, is lower than -8. Information criteria, yes, are from range -infinity to +infinity. Yes, so if we have information criteria 20, 25, yes, positive, 20 is smaller than 25, but if we have negative values of information criteria, -10 is smaller than -5, yes, so smallest value is the better in evaluation. We have here exercise 27. Use data of stock prices of Microsoft, Boeing and Amazon Corporation. We have these data downloaded from Yahoo Finance, yes, and I provided these data to you, to your school email addresses, and we'll calculate log returns. Yes, so from empirical data of stock prices, we'll calculate, for example, in Eviews software, log returns, and we'll determine the order of Arma PQ processes. Yes, if the model makes sense, forecast the time series. So probably we expect, yes, that we will find some significant Arma PQ processes, at least in one, I hope that at least in one of analyzed time series, recalculated to log returns. Yes? So on the basis of good model, we will try to create the forecast. Okay, so I downloaded for you from Yahoo Finance 3 files, yes, 3 development of prices of Boeing company, Amazon company and Microsoft. So we have here 3 sheets in this document which I already sent to your school email addresses, and we will try to open this in Eviews. We will open from all these companies the close prices, yes? So it's necessary to close this document because Eviews cannot open the document which is already opened in another software. So there is Eviews, and we'll click on File, Open, and the foreign data as work file. So we will find this. Yes, it's named like this. Okay, so there. Predefined range. Yes, you can see that we have here Boeing, Amazon, Microsoft. So we will start with Boeing. Yes. So Boeing. Okay, we'll click on next, and finish. And there is a first work file with Boeing prices, yes? Okay, no, close. We will move this and we will open everything for the first time, yes? So again, please click on File button, again open, and foreign data as work file. we will find in downloads. I have in downloads, yes, this file open and predefined range. For example, Amazon now. Amazon. Okay, so there we have Amazon prices. So we can click on Finish button, yes, and there is another window, another work file. And finally, we'll click one more time on File button, Open, and for any data as work file. We will find in our documents this spreadsheet, Open, and predefined range. We will select Microsoft, am I right? Boeing we have already opened, Amazon and Microsoft now. Finish, and we have another third work file, yes? Okay, so I already said that we will try to use close prices, and after we will try to calculate from these close prices the log returns. Yes, we will use we'll try to use model of time series of prices and the time series of log returns. So first, for example, this window, yes, where is close price? Here, close price, so we will check close prices. We will click on View button and Graph. Okay, so there is the development of close prices of Boeing company. There is another group where we have close prices of Amazon company. So we will open close prices. So there is a spreadsheet and we will click on View button and the graph, yes, okay. So there is the development of Amazon close prices, and the final we have here Microsoft. So again, close prices. So we can double click, and there is a spreadsheet with data. So please click on View button, Graph, and okay. And there is development of close prices of Microsoft company. So we have here three close prices, and now we will check, for example, the correlograms. And we'll check the correlograms if we have these charts here. So please click on View button, correlogram, and the correlogram of level. Okay. Again here, View correlogram, correlogram of level. Okay. And also in the case of Microsoft, View correlogram, okay. So here and here the development is similar. You can see that we have here very significant coefficients. In the case of autocorrelation function, very close to 1. Yes, very close to 1, so very strong dependence between the neighborhood values. Yes, one coefficient in the case of partial autocorrelation function is significant. Yes, so there is very strong autoregressive process. The same is here, but maybe also the second column, yes, is statistically significant at the 5% significance level. So maybe this will be a little bit different situation in autocorrelation structure. So we will remember, yes, these three charts. Now we will calculate log returns, yes, because in our presentations we talked about log returns. So we will calculate, for example, here in this window, we will write a series and we will name, yes, for example, log returns and Boeing, yes, okay. So equal sign, we will use log, and in parentheses we must calculate the ratio close divided by close in time -1. Perfect. Enter, and we have here log returns for Boeing. Here we will calculate log returns for Amazon. So series log returns Amazon. Okay, equal sign. We will write here log, and in parentheses will be again the ratio close prices divided by close prices in time -1. Close divided by close -1. Okay, enter. And finally, here we must click here to this window, and we must write command series log returns Microsoft equals sign log, and in parentheses we'll write close divided by close time minus 1. Okay, perfect. So we have here 3 log returns. So we will open, yes, we will open these 3 new time series. So log returns of Boeing, and log returns of Amazon, and log returns of Microsoft. And we will check the charts, yes. We will check the development of these 3 new time series. So please click on View, Graph, and OK. Perfect. View, Graph, and OK. Perfect. And finally, in this third example, View, Graph, and OK. Perfect, yes. So we can see that all developments are a little bit different, yes, because we have here logarithms from ratio, fluctuation is around 0, 0 mean, 0 conditional value, and we will check the correlation structure in this time series. So we'll click on View, Correlogram of level. Okay, and again here View, correlogram of level, okay, and here View, correlogram of level. Perfect. So, according to these correlograms, yes, we can try to say something about the correlation structure. Maybe we expected, yes, that these first columns will be higher, yes, than the second one, yes, according to p-value here and Leung box Q test. There is no correlation. At the 5% significance level, this hypothesis is not rejected, yes. So maybe there is auto-regressive or moving average process. Maybe there is not significant, yes, but we will try it. Here, there is no correlation. This hypothesis is rejected. Maybe these coefficients are significant, so maybe there is some auto-regressive or moving average, yes, process. And here, probably because I'm interested in absolute values, yes. So if I reverse this first column on the right side, yes, that is possible to see exponential decreasing in the case of autocorrelation coefficients. And one coefficient of partial autocorrelation function is statistically significant, yes. So probably autoregressive model of the first order. There will be maybe Arma process, Arma 1.1. Yes, we will try it, we will see. And here we don't know, yes. We will try also Arma 1.1, yes, but because this first coefficient is not significant, maybe this will be white noise process, and this will not be suitable for modeling and predicting, yes, so we will see. Okay, so we can start, we can click on quick button, estimate equation. We will start, for example, with this one, because I hope that this will be easy. So we have here log returns of Microsoft, log returns Microsoft, okay. And we will use AR1, yes, AR1. Okay, yes, in options, don't forget to set ordinary least squares. I hope that everything is alright, so we can click on OK. And there will be model, yes. I said that I think that this is auto-regressive model of the first order. This coefficient is statistically significant at the 5% significance level. Darwin-Watson 1.98, so probably we explained enough variability, and there will not be autocorrelation. We will check, yes, if we explained everything. Click here on View button, and we have here residual diagnostics, and we have here correlogram Q statistics. Yes, so yes, click on OK, and we will check the correlogram, and which correlogram? No logarithm. This one. This is correlogram of our residuals. This is correlogram of our residuals. Yes, correlogram of residuals. There is no system, yes? There is no system, zero hypothesis, there is no correlation, is not rejected, so there is no system in our residuals. So probably we explained our data, yes? So this is probably the good and optimal model. So we will name this model. We will return back, yes, here view button and estimation output. Yes, so this is our model, and we will name this model name. And because this is third time series, yes, we will name this like equation 3 space Microsoft, yes, equation 3 space Microsoft. Okay, yes, so we can close this because we already saved this model, yes, and we can continue. For example, here, in case of Amazon, yes, so we will click here because we need to model, yes, here. Quick button on the top, estimate the equation, and there we have log returns of Amazon, so log returns. Now we will select, yes, Amazon, space, and I don't know if I'm right, yes, so I think that we can start, for example, with AR1 and MA1, yes, AR1, space MA1, and we will see, yes. So I can click on OK button, and you can see that autoregressive coefficient is not statistically significant, and moving average is also not statistically significant. Maybe we will try to delete one of these coefficients, yes, and it will be better. So we will try to remove, for example, moving average. Yes. So we will click on estimate. We will zoom this, and we will delete moving average. Yes. And we will leave here only auto-regressive part. Yes. And we will try. Okay. So now you can see that coefficient phi is very small, minus 0.13, yes, but is statistically significant at the 5% significance level, yes. We can try experiment, yes, to change this phi AR1 to MA1, yes. So again, you can click on estimate. We can zoom this, and instead of AR1, we can write here MA1. Yes, okay. And you can see at the 5% significance level, this is not significant. Yeah? This coefficient theta is not significant at the 5% significance level. So the previous situation was better. So again, we will click on estimate. We will return back moving average MA1 to AR1. Yes, this is our situation. You can see Darwin-Watson statistics 1.97, and we will try to check the residual control. So please click on view. There is a residual diagnostics, and we will check correlograms Q statistics. Yes, okay. And we can see that according to Young-Box-Q test, Young-Box-Q statistics, there is no correlation, there is no system, yes? Zero hypothesis is not rejected. You can see that there is no dependence in residuals, yes? So we have here residuals. We can click on view button, we can return back on estimation output, and we will name this model, yes, for the future purposes. So name equation 2 space Amazon, yes, space Amazon, and we have here another model. Now we can close this. Okay. Finally, here, again, yes, I said that maybe there is a combination of Arma, yes, process, so we'll click on quick button, estimate equation, and here we will use log returns of Boeing, yes, log returns Boeing, okay, and we will write here space AR1 as space MA1, yes, it's combination probably AR1 MA1. Okay, and we will try it, yes, we will try it, okay, and it's similar like before, yes, autoregressive part is a little bit more significant than moving average part, yes, so maybe we'll try to omit moving averages, and situation will be better. Yes? So please click on estimate, delete the moving average part, yes, from this equation. Okay, and still autoregressive part is not statistically significant. Yes. We can try to change autoregressive part to moving average component, so we can rename this AR1 to MA1. Okay, it is not statistically significant, yes, at a 5% significance level. One more thing, yes. We will try to use autoregressive model of the second order. So we will click on estimate and log returns. We will write here AR1 space AR2, AR1 AR2. Yes. So this is the last attempt. Okay, yes, there is significant, yes, there is significant parameter AR2, phi2, but we must, yes, we must use either both parameters, phi1, phi2, yes, or nothing. Yes, and probably because there is no correlation between the neighborhood values on the first block, yes, this process is complicated for modeling, so we will not be able to model Boeing, yes, so this can be closed, yes, closed, delete, yes. Okay, so we have here 3 windows with Boeing, with Amazon and with Microsoft, and only 2 models from 3, yes, were selected, only 2 models were selected. So Boeing doesn't have model because this model was not statistically significant. I saved here equation 02 Amazon, yes, and here I saved equation 03 Microsoft. Equation 01 Boeing doesn't exist, yes, because this one was not significant. So at the beginning I hoped that at least one model will be successful. So we have 2 models. So we will try to create 2 forecasts, yes, 2 forecasts. If you check this label where we have 252 observations, we will try to forecast the time series, for example, to the end of January, yes, and we will see the power of these two models, yes. So first, what is important? We need to add here a place for the calculation of forecasts. So we can double click here on 252 observations. Yes, and here where is written end date, we will try to write 01/31, for example, /2021, yes? Okay, so we will try to click on OK. Resize involves inserting 22 observations. Yes, we would like to continue, and you can see that now we have here 274 observations, so free spaces of for calculation of forecast. There is written only 29 because there is set 5 days working day. So Eviews probably knows that some day is not working day, yeah? So it doesn't matter. Yeah? This is just an experiment. So the same we will do here in the case of Microsoft. So instead of @last, we will write here the same format, 01/31/2021, okay? And yes, 22 observations, and we will see here, yes, the end will be 29 of January 2021, yes? So this is important for us, we will remember this end, yes? And we will start here, for example, equation 02, Amazon, we can open this model, we will click on view button, there we have a test for normality, yes, you can see the distribution estimation output. So there is our model with very weak coefficient phi1, yes, only minus 0.13. If you remember, coefficient phi in the case of autoregressive process, yes, in case of autoregressive process is between 0 and 1. It's something like a measure of dependence on the previous values. Yes. Okay. So this is our model, and we will click on forecast. Yes. And here there is a name of forecasted time series, log returns, Amazon F. Please write here Amazon and F at the end. Yes, we'll try it. Amazon F. Okay. Standard error, for example, SE. We can write here just SE. Yes. And forecast sample. So if you check this, our last date, yes, was 30 of December year 2020, yes. So we will start with 30 of December 2020, and according to our new range, the end is 29th of January 2021, yes. So start date 12/30/2020, as this end, and 1/29/2021. Yeah, so I hope that everything is all right. We can click on OK, and we will see the forecast. Yes, maybe you can see very small waves very small waves, and there is the end on the 7th, 8th observation, yes, 7th, 8th of January of year 2021. This is probably because this model is very weak and our coefficient phi is very weak, only minus 0.13, so there is not enough memory in this model. But we will try to add this forecast to empirical data set, and we will calculate our own confidence intervals. If you check here, there we have log returns Amazon forecast. This is the baseline mean, yes, of our forecast, and there is calculated plus minus 2 times standard error of estimates. Why 2? If we use classical 95% confidence intervals, yes, we are using, in the case of real data sets, the real data sets with a lot of observations, we have large sample size, we have more than 30 observations, yes? So if we have large sample size, the real data sets, we are using quantiles of standard normal distribution, and the quantile which is used in case of these confidence intervals, as for the case of alpha 5%, 95% confidence level, as is u1 minus alpha divided by 2, as plus minus quantile of the standard normal distribution 1 minus alpha divided by 2 times standard error of estimate, and the size of this quantile is 1.96, yes, 1.96. In the case that we have small samples, smaller than 30 observation, it's necessary to use student T quantiles, yes, with degrees of freedom ni. And ni is calculated on the basis of sample size and number of parameters in our model. We have a lot of observations, we have one parameter in our model, yes, but if we have a smaller sample size, yes, the values of student T quantiles are 2.014, 2.016, etc. So the values very close to value 2. So the authors of Eviews in general used value 2 universal as general value 2 instead of, for example, 1.96, yes, the value of the standard normal quantile, 97.5% quantile of the standard normal distribution. So we will remember this because we will use this later in creation of our own confidence intervals. So we can close this will not be necessary anymore, and we will calculate the forecast, the same forecast here in the case of Microsoft company. So there is our model, there is a distribution of residuals, estimation, output, yes. We use estimation output, and there is our model, yes, with only one AR parameter stronger, a little bit stronger, yes. Instead of 0, minus 0.13, there is minus 0.41, yes. We will click on forecast, and there log returns Microsoft F-like forecast, yes, okay. Again, we can write here SE because this is another window, yes, so it's alright. And if you remember, in the previous case, we said here 12/30/2020, the beginning, yes. And the end 1/29, so 29th of January of year 2021. I hope that everything is alright. So we click on OK, and here, maybe because this model is a little bit stronger, with a little bit stronger parameter of parameter phi of this model. As you can see that there is predicted first, second, third observation, maybe something after, and again, after is a constant as 0, yes? So this is again another forecast with confidence intervals. We will add this baseline mean to our empirical data set, and we will calculate our own confidence interval. So again, we can close this, and we will start here, for example, in this window. So we click to this window, and here on the top, we will start with writing, for example, series, yes, series, new name, log rit Amazon lower. Log rit Amazon lower equal sign, and now we will write here log rit Amazon f, log rit Amazon f, minus, and this is English speaking software, so we must use dot instead of comma. 1.96 times star, classical star, standard error. Where is standard? Here, SE, yes, SE, and enter. And we have calculated lower bound, and the same with upper bound. So we can copy this or rewrite series log rit Amazon upper, for example, yes, will be equal to log rit Amazon f-like forecast. Amazon f-like forecast plus 1.96 times standard error of estimate. Okay, enter. And the same we will calculate here for the case of log rit Microsoft. So again, yes, we can copy this, paste here, log rit instead of Amazon, we will use Microsoft. Okay, and if we have upper, so there is log rit Amazon, Microsoft instead of Amazon, Microsoft forecast plus 1.96 standard error, yes, and there is new file, and the same one more time here, instead of upper will be lower, so series log rit Microsoft lower equal sign log rit Microsoft forecast minus 1.96 times standard error, enter, and we have here the bounds. Okay, so we will start with creating of a nice picture. So for example here, first we must select log rit Amazon f-like forecast. After log rit Amazon, after, for example, lower and upper, yes, in this order, this is the best. Right button, open as group, yes, open as group, and there we have this 4-time series, so we can click on view button, graph, and okay, classical line, and the symbol. Okay, so there is calculated the forecast. We will do this thing. We will click on freeze, off, graph is frozen and does not update, okay. And we will close this original chart, yes, delete untitled group, yes. And this chart we will modify, yes. We will click on options button, and here you can find lines and symbols, yes. It will be good to change this green color to black color, because this is the confidence interval, yes. So this black, okay, apply, and okay, yes, apply, okay, And you can see that there is a forecast, there is upper bound, lower bound, yes. We can double click on this region, yes, and we can a little bit rename this log, read Amazon, and instead of F, for example, forecast, yes, instead of F, please write here forecast, yes, for example, with space. Log read Amazon forecast. Okay, this log read Amazon empirical data, yes, log read Amazon empirical data, and instead of log read Amazon lower, we will write here plus slashed minus 95% confidence interval. Delete everything, you can delete everything, we know that this is log returns, plus slashed minus space 95% confidence interval, and this last will be deleted. Yes, this last will be deleted. Delete this text. Delete this text. Apply. Okay. And everything is alright. Yeah? So we can see log returns Amazon forecast, empirical data, red color, and confidence interval. We know, yes, that it's the same length up and down. Yes. We can add here one line. Please click on line slash shade. Select here line pattern. For example, this one. Yes, line with 3/4 of points. And observation. We will write here the last observation. Yes, where was our yes, 12/30/2020. Yes, the last observation where we had empirical data. And from this observation, there is the forecast. Yes, so please click on OK. Perfect. Yes, so there is our start point, yes, of the forecasting, and this is the horizon of the projection. We can save this nice chart, yes, so we can click on name, and we will name this, for example, graph space Amazon, yes, okay, and you can close this. And the same we will do in case of Microsoft. So please, we must select log read Microsoft forecast. Yes, after log read Microsoft empirical data and lower and upper. Yes, again right button, open as group. Yes. And here we'll click on View button and Graph. Okay, we'll select line and symbol and OK. Perfect. There is development. We will freeze. We will freeze this chart. So please click on Freeze. Off graph is frozen and does not update. OK. And please close this original chart. Yes, we will work. Yes, delete this group. Okay, we can select here options, yes, gain options, and instead of green line will be black line, yes, okay, because we know that confidence interval is the same up and down, yes, okay, so we can apply this, okay. And there is the development. We can double click on the region, yes, and again in the same way we can rename the region. So log read Microsoft forecast. Yeah, this is the forecast. Here we have log returns of Microsoft empirical data. Here we will write plus/minus 95% confidence interval, and the last is deleted. So we can click on apply and OK. Perfect. This is very nice. And finally, we will adhere a line, yes, which denotes the start of our prediction. So we will click on line/shade. We will select, for example, this type, 3/4, yes, 3/4 of points. And here we will write, yes, 12/30/2020, so the beginning of our prediction, and after there is a horizon of our forecast. So you can see that is the forecast. We forecasted only 2 or 3 values, yes, and after the prediction is 0, yes. Again, we can save this chart, so please click on name, and we will name this like graph space, and this is the case of Microsoft. Okay, so if you check any chart and any of our prediction, yes, you can see that forecasting of these type of time series is not easy. We have very small amount of information inside the data set, yes, and very quickly can see that very quickly the forecast limits to the conditional mean, the conditional average, yes, the conditional mean value, which is in this situation the 0, yes. So this is very important information, and I think that we can continue. We will continue with characteristics of Arma processes. Let's have simple autoregressive model of the first order, yes. So here, for example, we have returns, yes, denoted like returns in time t equal to phi1 returns in time t minus 1 plus at, where phi1 is a parameter where for autoregressive part, yes, we know that the phi is smaller than 1, because we can imagine that this parameter phi is something like a measure of dependence, yes, between the neighborhood values, value in time t and value in time t minus 1, yes. It's not correlation coefficient, yes, it's something different, but it's a measure of dependence, yes, different than correlation coefficient, but a measure of dependence. So, because this is a measure of dependence, it is smaller than 1, yes. And AT is Gaussian white noise with variance sigma a squared. So again, finite and constant variance. An example of such a stationary AR1 model is RT equal to 0.9 times returns in time t minus 1 plus AT. So there is a strong, quite strong coefficient, yes, of phi. So quite strong measure of dependence between value in time t and in time t minus 1, yes, where AT is again Gaussian white noise with unit variance. Characteristics of Arma processes, we can continue. What is the unconditional mean expected value, yes, the mean expected value of returns in time t, unconditional variance of returns, yes, and unconditional standard deviation. What is it? Conditional mean expected value in time t minus 1, yes, of returns. Conditional variance in time t minus 1, yes, and conditional standard deviation. We can explain the differences. Yes, so this is a little bit theory which is here for you like supplementary material. So we can answer these questions. So the answers, yes, maybe you know this from other subjects of econometrics or others, yes. So we already know that unconditional mean, yes, expected value of returns in time t is equal to 0. As 0 mean, 0 expected value, or statistically non-significant value, yes. If the value is 0.00 something, and at the 5% level, statistically not significant, yes, it's equal to 0. Unconditional variance, yes, unconditional variance of returns, log returns, is equal to sigma a squared divided by 1 minus parameter phi 1 squared, yes, which is in our situation equal to 1 divided by 1 minus 0.9 squared, and this is equal to 5.26. This formula you can write, for example, to your notes, as if you want, for future, but you know that we don't have any midterm test or final test in this subject, but you can know this. So if you want to remember this, you can write it to your notes. This formula for calculation of variance of log returns. Unconditional standard deviation, yes. Standard deviation is every time a square root from variance, yes. So square root from variance of these returns, log returns, will be equal to square root from 5.26. And this, if you use calculator, will be equal to 2.29. Standard deviation is in basic units, yes. So in this situation, this is in log returns, and this previous value is in squared units, so we are not able to interpret. Yes, we are not able to interpret this value 5.26, but 2.29, yes, it's in basic units. So if we have here log returns, so this is in logarithms of returns. Yes, conditional mean expected value in time t minus 1 of RT is equal to phi 1 times r in time t minus 1. So in our situation, this strong coefficient 0.9 times log returns in time t minus 1. Conditional variance in time t minus 1 of log returns, you can see it's equal to variance in time t minus 1 AT. So in our situation, this is a variance sigma squared of A of white noise process, which is equal to 1. Because in case of white noise process, Gaussian white noise process, we have a 0 mean, and sigma squared equal to 1, sigma equal to 1, it's a standardized normal distribution. Yes, standard normal distribution with 0 mean and variance equal to 1. Conditional standard deviation, I already said this. Yes, square root from the variance and square root from 1 is equal to 1. Yes, conditional variance and conditional standard deviation is constant for traditional Arma models. It means doesn't change over time. Yes, it's finite and constant in time. Okay, so that's all. This is the end of our 7th seminar. I hope that this was again useful for you. And next week I will show to you other things, maybe a little bit more complicated, but it's live. So that's all today. I wish you the nice rest of this day, and I hope that I will see you on our 8th seminar. So that's all, and bye bye.